Okay, we have this question. We are expected to find the length of the tangent. So foremost we will have to have the figures. So let me draw this first. So this is a circle. Okay. So it's an approximate circle. Okay, all right. So next we need to have a quarter circle. So I will have to draw the quarter circle such that there is a hit there and the quarter circle is actually moving all the way up to this point. Okay, that's a nice hit. Okay, there is a point of contact. There is one point of contact. So now let me complete this. So there is a point of contact there. There is a hit there. Okay, all right. So this is a lovely circle, and there is a center there. So I'm going to take that point as a point of tangency. Okay, so we are only given this. We are given this alone. We are not given anything else. We are only given this. So let me draw this tangent. So this has a point of tangency there. Okay. So there is a point of tangency, there is a center here, and there is a point of tangency. Okay, fair enough. So now we have to find the length of AB. Okay, B is there, and we are given this distance. Let me take this as O, and let me place this point as M, and this one as P. We are given PM as 7 units. So this is given as 7 units. Okay, so you can try this question. I hope you all have got the solution. So foremost, let me write this. This is the geometrical property of two circles having a point of tangency. Okay, there's a point of tangency here. Okay, let me take that point as T. Two circles having a point of tangency at T. By geometrical theorem, or I would say by geometry, the line passing through the point of tangency will pass through the centers of the circles. Okay, that is the important law. Now, having mentioned that, let me draw that point of tangency. So there is a hit, right? Okay, fair enough. Now, having given that, I'm going to use next property. By tangent radius theorem, the radius makes an angle of 90 degree with the tangent. So from here there is a 90 degree hit. Okay, there's a 90 degree hit. Now let me take this radius as r. Okay, now if I were to talk about P O or OP, if capital R is the radius of this large circle, then clearly this distance is R, and if I were to get this distance, I want to know what is this distance. So to get this distance from R, I have to take away the value of smaller. Okay, so this idea PT is equal to capital R, OT is equal to small r, which is also equal to OM. Now I want to know what is the distance of OP. So OP is equal to this distance PT. From PT you subtract OT, so which is going to be from capital R you take away small r, so this is going to be my OP. So OP is equal to capital R minus small r. Okay, now why do we need this? Consider triangle PMO. I will be considering this triangle. So by Pythagoras theorem, what do we have? PM squared plus OM squared is equal to OP squared, right? So PM squared is what? 7 squared plus OM squared is R squared is equal to OP squared is capital R minus R squared. So this is what we have got. So I'll take this as equation 1. Okay, fair enough. So now, having got this, what I'm going to do is I'm going to connect A with O. Okay, I'm going to connect A with O. So let me do the connection. Connect A with O. So connecting A with O, what do you get? Now this is going to be 90 degree. Why this is 90 degree? Since AB is a tangent. AB is a tangent and OB is a radii. Okay. So I'm going to write that here. Since AB is tangent and OB is equal to R, so therefore angle at B will be equal to 90 degrees. So this is 90 degrees. So we got a right triangle there. Okay, so this distance I know, which is R. When I say I know, it means we have taken that representation as R. The all important fact is we will have to get this AO. Now what I would do is I would actually take AO to be as some x. So now we will consider triangle ABO by Pythagoras law. What do you have? AB squared plus OB squared is equal to OA squared, and AB squared, I do not know AB squared, that is required, so place that. OB squared is R squared and OA squared is x squared. So I now have x squared. Okay, let me take this as equation 2. No need to have anything else. So equation 2 is that X squared is equation 2. Okay, that's fair enough. Now what would I do next is I will drop a perpendicular from O to AB. So I will draw this from O to AB. I will take that point as some W. Now this is clearly 90 degrees, right? Now what I would do is I will consider triangle AWO. Now this entire length is R, this length is R, so this is going to be capital R minus R, this length. Okay, so AW squared plus OW squared is equal to OA squared. OA squared is X squared. AW squared is capital R minus R squared, and OW squared is 7 squared. So this is going to be equation 3, right? So now 2 and 3 can be connected. So let me go to the next slide. So consider 2 and 3. So what is that 2? We got X squared is equal to R squared plus AB squared, and X squared is equal to 7 squared plus R negative R the whole square. This is 2 and this is 3. So equating 2 and 3 we get, so R squared plus AB squared is equal to 7 squared plus R negative R the whole square. This is what we have got. Okay, now there is a value we have, R negative R from 1 R negative R the whole square is equal to 7 squared plus R squared. Okay, we have already got that. So substitute, I'm taking this as 4. So therefore 4 becomes R squared plus AB squared is equal to 7 squared plus R squared. Now R squared gets cancelled. So AB squared is equal to 7 squared plus 7 squared. What is that? That is 2 times of 7 squared. We need length of AB. AB is equal to root of 2 times of 7 squared, which is equal to 7 times the root of 2. So AB is equal to 7 times the root of 2 units. Okay, so that is a lovely question. Thank you everybody.